I have opened a Python notebook from the Google Colab, and objective of this demonstration is to program for generating the coefficients of linear regression. So the model we are using is y equals a plus bx, where x and y are the vectors from the data, and we are interested to get the best and the optimized values of A and B, which are from the least square curve fitting expression. So the formulas have been written. The notebook of Python, it provides the facility for writing the text and writing the equations. So I'm using that one. The spotlight. Okay, so this is going to be represented as a title. So with one hash, with the second hash, it goes to a smaller level, and so on and so forth. Uh, if you would like to write an equation, so the LaTeX interface is provided in Python. So where the by a proceeding slash, backslash, and writing sigma, it is going to be printed as the sigma notation, capital sigma. So these are the expression where x bar is the mean value of x, y bar is the mean value for y, sxx is defined as the sum of squares of deviations of x. Likewise, the sum of squares of deviation of y are defined. And there is the ones sxy is the summation of respective deviations in x and y and their product. And finally, that has been summed. So to write a program, well, of course, there are the values of the slope from that least square regression analysis. B can be calculated. Sxy divided by sxx, and intercept can be calculated by a equals y bar minus b times x. So in the code block, I have imported the libraries with these commands, numpy as np and matplotlib.pyplot as plt. And yes, they have become the part of my program. Now let's read the data and keep on doing the calculations the way I have mentioned them in the text part of it. I will use variables to define the expression and then calculate accordingly, and finally A and B. So first step is to define the data vectors. So I define X as numpy array. So I can define the values from 1, 2, 3, 4, and 5. And then the Y. So I use numpy array or a different one, a range from 1. Well, it's very nice. So starting point, the stopping point, and the step, and it is asking for the data type as well. Well, it is good to define the data type. So I define data type here as float. And for the other, with the other command for creating an array of similar type, I say 1 to 6. And then I define the data type. And again, I appreciate floats. So let's see whether it is correct. So the vectors have been generated. Well, I can access the values x and y. Okay, so both arrays have been created, and the dot is the expression that these are the float values. Now, let's move forward. So first thing which is required is the x bar, which is the mean value of x. So I can simply call a function from numpy. So mean of x, this is fine. X bar variable has been defined. It is mean value of x. Likewise, y bar is the numpy mean value of y. This is fine. Okay, mean value of y. Now the next thing that I have to define, the next variable or the is the sxx, sxy, and syy. These are the required computations. So I define the calculation vector s. Before that, I define a calculation of cxx. So it is equal to x, the vector, minus x bar. So it will generate a complete vector for cx calculation, and I need a square of it. So I calculate it like this: cxx times cxx. It is just like computing the dot product, and then I require a summation of it. So this is the summation, right? And then sxy. So this is to be calculated as, let me first define cyy. So it is y minus y bar. So this is going to be calculated. And now sum of sxy, this will be x minus x bar, which is cxx, times cyy. And then I can apply the summation over the whole vector. So this is going to be calculated. I'm really trying hard to stay consistent. So I have computed SSX, right, by creating a vector for xi minus x bar. So which vector was cxx, and then I computed the vector cyy as yi minus y bar, and then I computed the summation. So with these parameters, I can then calculate the values of b, which is slope. So slope is s xy divided by s xx, and a will be y bar minus b times x bar. And finally, I can get the values. So I write print slope value, which is b, equals b, and then print intercept a equal a. So behold the critical step. Oh, it's perfect. It's perfect. Slope is 1 and intercept is 0, as we were expecting, right? And now let's to see that one in a plot. I first go for a plot, plt dot plot. So x, y, the data points, and show them as red circles, all the points. And plt x label is x, and plt y label as y. And in the ideally Python, you have to write another statement as plt dot show, right? This is not required in Spider Python and Jupyter Notebook. So a plot with a few elements, yes, it's all there, right? And to show my straight line that we have calculated, so I define another vector xs as numpy linear space. So I start from -5 to 5 with 100 points there. And then I calculate ys as a plus b times xs. And then on the same plot, I plot xs and ys. And I plot it as a blue line. And then I add plt legend. Since now two attributes are going to appear. The first one is the data points, and the second is the fitted curve, least square fit. Yeah. So the straight line that passes through all the points, this can be generated by this simple algorithm. Now, the only inputs that led to all this calculation were the data points, right? And with the algorithm of least square fitting, we have got to the straight, the linear fit to those data points. So you can test this algorithm. This is a good point to stop at. So I turn off the recording now.